sticks. Travelling at speeds of 150 kilometers an hour, a lot of engineering goes into packing that sort of punch. See you after the break. Later, we look at ice hockey sticks. Elegant pieces of curved wood wielded at speeds of 150 kilometers an hour. But first, your tank's almost empty, but you're gambling you'll have enough petrol to make it just that little bit further. Well, when you're on that long walk to the nearest petrol station, you'll be glad someone had the bright idea of manufacturing these handy plastic petrol containers. Plastic petrol containers are made from granules composed of concentrated colorant and a UV-resistant additive. They're mixed with white granules, which is the primary material, called high-density polyethylene, and recycled plastic, which has been ground up. It's all dumped into this milling machine, mixed together and melted. The melted plastic will be blown into this mould made of high-quality, dense aluminium called an aviation type. The blow moulding produces a soft plastic tube. This is cut and placed in the mould, where a nozzle pumps the plastic into the mould shell. The container is unmoulded and moves along on a conveyor. But that's not the only way to mould plastic. There's the rotation method. Low-density linear polyethylene is poured into the bottom of the mould. The mould has a cover which will be closed, then placed on a steel support. This support is articulated by an arm on two rotation axes simultaneously. This action allows the plastic powder to distribute itself throughout the mould. The mould is placed in an oven at temperatures of 310 degrees centigrade. About 15 minutes is needed for the powder to melt, and another 15 minutes to allow the piece to adequately cool before unmoulding it. The mould cover is lifted off, and the plastic piece is unmoulded. Other things are made here too. Here they create a cover for a stationary bicycle. Openings are cut with a pneumatic tool. When the holes have been drilled, the casing is complete. We return to the blow moulding process. Residues build up, which have to be eliminated. These surplus pieces are cut with this small saw, and the now hardened scraps are sent to be reduced into granules, which will be newly added to the mixer to make other plastic containers. A small pneumatic drill pierces the container's vent hole. The containers continue their journey by conveyor, where a set of robotic arms awaits. The final elements are attached, such as the pouring spout. Then a stopper, equipped with a rubber washer, prevents leaks. And finally, the cap of the neck is automatically screwed into place. Depending on the thickness of the mould, 120 containers an hour are produced. The rotation process takes a little longer. Finished containers are now ready for packing and delivery. And if you're still not clever enough to remember to buy one, you'll at least know how they're made. Few things are as elegant as curved, polished wood, especially when travelling at 150 kilometres an hour and driving a slap shot right past the goalie. A lot of engineering goes into creating an ice hockey stick that packs that sort of punch. The Irish, some 1200 years ago, were playing hurling, a form of hockey on grass. In the 17th century, Amerindians used curved sticks in a game they called batagaway. Ice hockey as we know it today was developed by British soldiers in 1855 at Kingston, Ontario, as a pastime during Canada's long winters. Making a hockey stick requires the melding of several pieces of wood and fiberglass. These sticks are all modelled on great hockey professionals. The shaft is made of a piece of poplar, onto which they glue two thin strips of birch. This is placed on a circular conveyor, equipped with a press which holds the pieces together while the glue dries. Then a multi-bladed saw cuts the wood into 3 identical stick shaft pieces. The shafts are moved to a precision sander, where they're reinforced with fiberglass. A roller applies a coat of epoxy resin, a type of glue, onto which they place carbon-reinforced fiberglass. Once the resin has dried and hardened, the stick shaft is placed in an individual mould and cooked in this press, heated at 80 degrees centigrade for 12 minutes. The shaft then goes to a milling machine equipped with diamond-headed knives which round the edges. A finish is applied to the shaft which brings out the grain of the wood. Now they glue small blocks to the end in order to attach the blade. Urethane glue is used, which resists water and humidity, perfect for hockey sticks. A slitter cuts the shaft and wood blocks in order to slide in the blade. And the machine inserts the glue and the blade into the stick shaft. The stick is placed on a conveyor, leading it to its next step and giving the glue a chance to dry. Both sides of the blade are sanded to thin them out. These sticks are replicas of those used by hockey professionals. This computer-controlled digital lathe cuts the blade with data stored in the computer's memory. The blade now has to be curved. It's steamed for a minute, allowing humidity to penetrate the wood, making it flexible. Then the blade is placed in this curved mould, where it's heated for 50 seconds at 55 degrees centigrade. The blade is then worked by hand. The new blade is compared with a pattern of the famous hockey player's stick to obtain precisely the same curvature. Now the blade is sanded down to the desired thickness. But the blade must also be reinforced. A fiberglass cloth is soaked with epoxy resin. They get rid of air bubbles, then put it into an oven to dry at 32 degrees over 24 hours. The surplus fiberglass hardens and is cut with a bandsaw. A steady hand is needed to do this job. Finishing is done with this circular sander. Finally, the blade is dipped into this epoxy resin to give it a nice luster. All that remains is a paint job. Company logos are applied via silk screening. Besides the 6,000 personal models of professional hockey players, this company produces 65 other models. Each week they make about 40,000 sticks, which means 1,600,000 a year. That's a lot of slap shots.